Good morning, good afternoon, good evening, ladies and gentlemen. And in today's video, we're going to be taking a look at Pythagorean Theorem and everything that comes with it. So before we get started, we have to remember, first and foremost, what is Pythagorean Theorem? Before we look at Pythagorean Theorem, we have to understand what these sides are called. So assume you have yourself a missing angle here, theta. Use our nice red lightsaber here, theta. This is our missing angle. If this is our missing angle, remember from the solving the trig ratios video, then the angle right across from it would be the opposite. And the angle right beside it would be the adjacent. C is the one that never changes. C is the one that's directly across from the 90-degree angle, and it's the largest side. We give it the name hypotenuse. Okay. Now, you always have to remember, it's always the largest side. Okay, and it's always right across from the right angle. All right, the other two sides, A and B, doesn't really matter where you put them. You can put A over here and B over here, or vice versa. Does not matter. That position gets changed every now and then. The C is the one that will always, always, always be there with your largest side. That brings us to the equation. Now, I'm not going to go over the formation of the equation in this video. I'm simply going to go into it. If people want me to make a video of the proof of Pythagorean Theorem and how it works, I can definitely do that as well. So the equation should be a squared plus b squared is equal to c squared. So the sum of the squares is equal to the square of the largest side. So let's take a look at how we would use this equation in finding our sides. So let's take a look at the first example here. And the first example is telling us to solve for the missing side x. Now, these are two various examples with two separate situations. You can see in part A, the missing side is our C. How can I tell it's my C? Because it is the side that is directly across from my 90 degrees. So because of that, we set up our equation, a squared plus b squared, in this case, 27 squared plus 20 squared, or 20 squared plus 27 squared, either way, should give us x squared. So for this one, you're just going to continue on. So 27 squared, you're going to get 729 plus 400 for the 20 squared. X squared is just x squared. Add these two together, get you 1129 is equal to x squared. Now, a common mistake that people make is they would leave it at this point and say, okay, I'm done. Well, that's the thing, though. You didn't solve for the c. You solved for the c squared. You want to get this x by itself, in which case you want to get rid of the squared. To get rid of the squared, you want to put a roof over both sides, the square root, as they say. Once you do that, the squared goes away, leaving you with the x. And the square root of 1129 going to give you a decimal number. Let's try to make it in 2 decimal places. 33.60. Now, our answer is not complete yet because we are forgetting our units. So this is in millimeters, so this should be in millimeters. Now, there's one thing to note. First and foremost, when you take the square root of a number, you should always have the plus and the minus. Why are we not using the minus here? Because for geometry, it does not make sense to have a negative dimension. Basically means you're like sucking into yourself like a black hole of math. So you're always going to use the positive answer. And 2, we can check that we're right because we know this side is supposed to be the biggest side. So if this side is 20 and this side is 27, this being 33.60, well, 33 is definitely bigger than 27 and 20. So it is the biggest side. Therefore, my answer is correct. Okay. Now that's one type. That was a very easy type. Why? Because you just have to straight up put everything into the a squared plus b squared is equal to c squared equation. Part B is a different type. In part B, you are trying to solve for the x, and the x this time is not the hypotenuse. The hypotenuse, if you go directly across from the 90-degree angle, is the 280. So if we're plugging it into our formula, doesn't matter where you put the 135, if you make it the a or the b, doesn't matter. I'm going to make it the a, so 135 squared plus b squared, which we know is x, so we're going to put that in as x squared, is equal to 280 squared. So we are still using a squared plus b squared is equal to c squared. The difference in these two questions is the x that was missing here was my c. The x that's missing here was either my a or my b, doesn't matter which one you make it. Okay, so just like we did before, let's expand. All right, so you're going to get, I'll write the x squared first here, x squared plus 135 squared is 18,225. It's equal to 280 squared is 78,400. All right. Now, you can't take the square root yet. Just like we did over here, we took the square root because we had the x by itself. We are trying to isolate for x here. So we have to get the x by itself. To do that, we have to get rid of the 18,225 first, which is adding, which means we are going to subtract from both sides 18,225. Remember those analogies? How do you get rid of a positive influence? By putting a negative influence. Don't try that out in real life. So, x squared is equal to, when you take that subtraction, 60,175. Now we are in the same situation we were here. Want to get rid of the squared? Take the square root. So take the square root of both sides. Once again, you're only using the positive answer. So x should be 245.31 meters. And that is my complete answer. And that is the only 2 situations you will get. In this next example, I'm going to compare the difference between finding a side using Pythagorean Theorem and SOHCAHTOA from the last trig ratios video. I want to show you the difference.